Welcome to today's analysis of a massive shift happening right now in robotics. Humanoid robots aren't just fascinating AI demos anymore. They are rapidly becoming a hardcore global mass production race. The real question we're facing isn't can a robot walk anymore. It's who can actually manufacture thousands of these reliable robots, strictly control the costs, secure the components, and then successfully deploy them inside real factories.
To really grasp the stakes here, consider this projection. Goldman Sachs estimates the humanoid robot market could hit a staggering $38 billion by 2035. That number fundamentally changes what this market means. We're moving from building one cool standalone machine in a lab to scaling up an entire global industry.
There's a stark contrast we need to acknowledge. A small, software-focused AI prototype can look incredibly impressive on camera, but the reality of mass production demands something entirely different. It requires high yield, raw efficiency, intense cost control, and absolute supply chain discipline. That's exactly where the terms of this competition completely change. Let's look at the first major hurdle, the supply chain bottleneck and its critical components. Because AI software alone just can't build this industry. Humanoid robots demand a highly complex network of physical parts. We're talking actuators, reducers, sensors, batteries, specialized hands, controllers, AI chips, and crucial safety systems. Whichever company controls these physical components is gonna scale faster. If you can't control component quality and drive down costs, you'll simply be stuck making expensive prototypes. Make no mistake, this is absolutely a supply chain race.
This brings us to our second point, robot foundry logic, or moving from automotive to robot parts.
This introduces a concept we're calling robot foundry logic. The strategy here is incredibly practical and powerful, leveraging an existing automotive supplier base and manufacturing infrastructure as the foundation for a future robot supply chain. Companies like Hyundai Motor Group, particularly through Boston Dynamics, are showing us exactly how this strategy plays out in the real world.
Rather than trying to build a complex supplier network from absolute zero, you bridge traditional auto parts over to complex robot components. It goes like this. Step 1, start with established auto suppliers. Move through Step 2, which is utilizing existing manufacturing infrastructure. Then, finally add Step 3, the robot-specific layers, things like advanced actuators and sensor fusion. By tapping into established production schedules and logistics, you vastly accelerate the whole scaling process.
Moving on to Section 3, Field Reliability and Practical Indicators.
When you're operating inside a real high-volume factory, the ultimate business question boils down to this. Can it avoid stopping the line? Practical factory performance and day-to-day stability matter far more than any flashy capabilities we see in promotional videos.
So what are the true indicators of operational success? Well, we're looking at runtime, meaning stable operation without failure. Then there's repeatability for consistent movement. Next is recovery, or bouncing back from small errors without human intervention. And of course, safety while operating securely right next to human workers. In the manufacturing world, a robot has to be judged by these hard, practical numbers. Field reliability is the true battleground here.
Finally, Section 4, the physical AI advantage and Korea's unique opportunity.
If we map out this shift from demo to real manufacturing, a very clear pattern emerges. Historically, South Korea is incredibly strong in manufacturing challenges that demand massive scale, high yield, and tight cost control. We've seen them execute this exact playbook in semiconductors, shipbuilding, and battery tech. When you combine that track record with their deep existing experience in smart factories, IoT, and connected systems, they naturally support a dominant position in this emerging market. Here's how that actually looks in practice. Smart factories already generate massive amounts of site data. Think defect patterns and downtime records. When humanoid robots step onto these facility floors, they add a whole new layer of robot operation data, like movement and task execution. The synergy between Step 1's site data and Step 2's operation data creates Step 3, a continuous, highly powerful, physical AI learning loop. Korea's real opportunity here isn't just about buying or using robots. It's about manufacturing them, deploying them, and actively training them inside real operating factories.
So the crucial takeaway for us today is this. Humanoid robots aren't just getting smarter. They're becoming significantly harder to manufacture at scale. This is a hardcore manufacturing challenge now. The question is, which market has the industrial discipline, the intricate supply chain coordination, and the smart factory experience to ultimately win this race for yield and scale?
Thank you for joining today's analysis, and we'll leave you to ponder that question.